Today we're going to look at abstraction. Modern systems are growing ever more complex, and the ability to use abstraction to reduce the complexity of interacting with these systems is critical to successful operation. Humans can only manage 7 plus or minus 2 pieces of information at one time. An abstraction is a general and simplified representation of something. You use abstractions all the time, although you probably don't refer to them as abstractions. You couldn't think or speak without abstractions. Words, ideas, concepts, maps, models, symbols are all examples of abstractions that we use every day to think about and talk about the world. Our ideas and concepts are abstractions, informed through a process of leaving out details of the specific things that the idea represents and condensing information in order to focus on relevant aspects of the object or objects we are representing. Some of the most abstract examples of abstractions are the words we use in our everyday language. For example, our concept of a chair is general enough to represent any and all chairs, whether it's a rocking chair or the blue chair that you're sitting in, maybe the comfortable chair that you have at home. Unlike maps, models, and floor plans, which have some visible similarities with the objects they represent, a word is completely abstract. Here's some examples of abstraction and abstracting. Abstraction. An idea or concept is a general representation of something. Abstracting. Thinking in abstractions is a fundamental part of human behavior. Abstraction. A map contains less information than the actual roads the map represents. Abstracting. We create a map by including only those details that will help us achieve the purpose of drawing the map. Abstraction. A model airplane contains less information than the real airplane it represents. Abstracting. We create a model airplane by including only those features of the plane that make the model useful for our purposes. Abstraction. A floor plan contains less information than the real space it represents. Abstracting. We create a floor plan by including only those spatial features that are relevant to why we're making the plan. Abstraction. A word contains almost no specific information about the object it represents, other than their definition. Abstracting. Learning that words represent things is a fundamental skill in learning to speak and read. Abstraction. A constant, such as the numeral 5, represents any one thing, the value 5. A variable, such as the symbol x, can represent any number. Abstracting. We use variables to make our programs more general and more useful. Abstraction. The square root method simplifies the process of calculating a square root. We do not need to know exactly how it's done. Abstracting. We create methods to make our computer programs easier to understand and to use. Abstraction in computer science. In computer science, abstraction is a technique for managing complexity of computer systems. It is the process of simplifying, condensing, and encapsulating, and is an important problem-solving skill. Abstraction is the removal of unnecessary information so a computer program can be as efficient as possible. Abstractions in hardware and software help to reduce complexity and make computer systems easier to use and to understand. Computer programming languages contain constants and variables, both of which are abstractions. Here's an example of abstraction. The square root method calculates the square root of any number, x. For example, the square root of 5 is 2.236. Computer languages have procedures that perform certain calculations for us. Abstraction works by establishing a level of complexity on which a person interacts with the system, suppressing the more complex details below the current level. In computer science, the programmer works with an idealized interface, which is usually well-defined, and can add additional levels of functionality that would otherwise be too complex to handle. For example, a programmer writing code that involves numeral operations may not be interested in the way the numbers are represented in the underlying hardware, for example, whether they're 16-bit or 32-bit integers. And where those details can be suppressed, it can be said that they were abstracted away, leaving simply numbers with which the programmer can work. In addition, a task of sending an email across continents would be extremely complex if you start with a piece of optic cable and basic hardware components. By using layers of complexity that have been created to abstract away the physical cables, network layout, and presenting the programmer with a virtual data channel, this task is manageable. Using an interface to simplify a process. Software programs such as Microsoft Word and Adobe Photoshop often provide features that automatically convert a file to a new format without the user having to know any of the details about individual formats. For example, going from a Word document to a .pdf. Banks provide simple features to transfer funds from one account to another while hiding the underlying communication and security needed to ensure the privacy of such transactions. Video editing software provides features to combine video files, allowing the user to focus only on the task of transforming the video or photo rather than on the lower-level concepts of bit representation. Gravity and resistance. Consider developing a software-based physics engine that would be used to simulate the gravity and other physics laws in a simulation for a video game. In reality, objects moving through space are affected by resistance from wind or water in a very complex process. A physics engine might simplify this down to a simple coefficient affecting your movement through water. Move half speed in water moving against you and double speed in water moving with you. An avatar in a video game would move slower when against the flow of water and faster when walking with the flow of water. Wind. Wind has a calculable effect on the trajectory of projectiles. For example, a strong crosswind will push a golf ball off course. And when wind changes, this effect becomes increasingly difficult to calculate. Many games disregard this effect when calculating paths. Note that reduction eliminates a number of complex calculations, but it also introduces a level of inaccuracy. In summary, we group information into chunks, such as objects in programming. We can manage more complicated pieces at once. Java classes and objects help programmers write complex software. Review. Abstraction occurs A. When computer operations at the hardware in computer operations at the hardware low level only. B. In computer operations at the application high level only. C. Primarily at the electrical hardware level. Or D. At any level and stage of operations. I'll give you a moment to consider the options. The correct answer is D, at every level and stage of operations. Abstraction occurs at every level and stage of computer operations. Here's another question. An airplane simulation to train new pilots on typical takeoffs and landings is designed specifically for cargo planes. Which variable does not need to be included? A. Weight of the aircraft. B. Number of crew for the airplane. C. Where the cargo is located in the cargo hold. Or D. Number of monthly bird strikes for this type of aircraft. I'll give you a moment to consider your options. The correct answer was D. The number of bird strikes are not needed to practice typical takeoffs and landings. Here's another review question. Before the world's largest ocean liner, the Queen Mary II, started construction, a 15-foot model is used in a 600-meter water basin using sophisticated computer simulations. Which of the following is not a benefit of such simulations? A. It assists in selecting the optimal hull design of the ship for all weather conditions. B. It helps to determine the size of the crew necessary to manage all the ship's needs. C. It allows testing of dangerous water conditions without danger to people or ship. D. It can save money by not using a faulty design that is very expensive to alter. I'll give you a few moments to consider your options. The correct answer was the simulation would not help to determine the size of the crew necessary to manage all of the ship's needs.